Okay, guys, everybody up here, let's look at Unit 2, Lesson 2, so 2.2. So what we did last time, we're solving simple inequalities. A simple inequality is something that looks like this. Okay, simple means there's only one inequality to worry about. That's what makes it simple. Your strategy when you deal with a simple is to get all the x's on one side and all the numbers on the other. What would you like to do first here? What do you want to move where? I mean, yeah, so I could move the 4 over to here. So someone said subtract 2x. Let's do that first, okay? That gives me 3 less than or equal to 2x minus 3. What's the next thing I want to do? Add 3 to both sides. If I add 3 to both sides, I get 6 less than or equal to 2x. Now I'm going to do what? Divide everything by 2. And I get 3 less than or equal to x. What I really like, I like to read it with the variable first. If you're reading from right to left, this means x is what? Okay, first of all, read it left to right. 3 less than or equal to x. Read it right to left. X greater than or equal to. That's what we're used to seeing, okay? So on a number line that looks like this, closed circle, shade to the right, what is that answer in interval notation? 3 to what? Infinity? What enclosures? Yeah, bracket on the 3, always a parentheses around infinity. So that's what we did last time, solving simple inequalities. Now, what we want to do in this lesson is handle compound inequalities. So a compound inequality is where I have more than one inequality. So you see something like this. Negative 13 less than or equal to 2x plus 3 less than 37, okay? Not too terribly difficult. What you want to do, you want to break this into 2 separate problems. What some people would do is they can treat this as one problem, like subtract 3 here and here and here, and they can keep them all going at the same time. I prefer just to break it into 2 problems. So I'm going to write down the first problem. Just copy down what you see there. Negative 13 less than or equal to 2x plus 3. The next problem, I'm going to copy all of that. 2x plus 3 less than 37, okay? See what I did? I broke it into 2 problems, okay? Nothing was changed so far. Now what do I have? I have 2 what? 2 simple inequalities. I just go solve each one, okay? So what will I do to solve this one? Subtract 3 from both sides. And I get what? Negative 16 less than or equal to 2x. And then I do what? Divide by 2. I get negative 8 less than or equal to x. How do I rewrite that where the variable comes first? X is, greater than or equal to negative 8. Okay, so that's the first one. You don't have to. If you can look at this and know how to shade it properly, that's fine. What I don't want is you to look at this and say like, oh, it's 8 and shade to the left, because really it's shading to the right. If you can look at this and read that it's x greater than negative 8, that's fine. What I'm ultimately after is the right answer in interval notation. So let's do this one. The one over here, I would do what? Subtract 3 from both sides. And I get what? 2x is less than 34. And then I do what? Divide by 2. Do I change the inequality? No, that's only when I multiply or divide by negative. X is less than 17. So I've got 2 conditions here. I want to represent those on a number line. That's my intermediate step to getting to interval notation. So which of these numbers is smaller, negative 8 or 17? Yeah, so just write negative 8 over here, 17 over here. I don't care about precisely where they are. So numbers that are greater than or equal to negative 8. What kind of circle goes on negative 8? Closed circle. Shade to which direction? To the right. What kind of circle goes on 17? Open. Shade in which direction? to the left, okay? What I just drew there, how many intervals is that? This is it's one interval, okay? One interval. And to get the numbers for this interval, all you have to do is just copy down these numbers. It's the interval from -8 to 17. What kind of enclosure goes on -8? Bracket, and 17? Parentheses. There you are, okay? So there are lots of places where mistakes can be made. Arithmetic mistakes up here, shading in the wrong direction, bracket versus parentheses. A lot of little places for the mistakes you want to stay on top of, but the formula for how we do this pretty consistent, okay? Let's look at another one. Pardon me, a tissue? Yeah, look on my desk behind my backpack, or there's some over here, but you can't, Jabari. Is it right there by my printer? See by the, oh, there they go. Okay, this is a compound or. The other one's a compound and. There's no difference here. I treat these are just two separate inequalities. 4x is less than -12, or 3x minus 6 greater than equal to 11. Okay. Solve each of these. The first one, I divide both sides by what? Divide by 4. X is less than -3. To solve the next one, what do I do? Yeah, add 6 to both sides, and you get 3x greater than equal to 17. And then I do what? Divide by 3, and I get x is greater than equal to 17/3. Okay? It's a fraction, but we're not going to do much with it, okay? Which of those numbers is smaller, -3 or 17/3? -3. So all I need to know is write the -3 here. Whatever 17/3 is right over here. Okay. Less than -3. What kind of circle goes on -3? Open, and shade in which direction? To the left. Okay. What kind of circle goes on 17/3? Close, shade to the right. Now, if you look at what I drew on the number line, how many intervals do I expect in my answer? 2. I got, here's an interval, here's an interval. Okay. This interval goes from what number to what number? -infinity to -3. What kind of enclosures? Parentheses. When I have two intervals, I just put that union sign. That means or. It's joining these together. What's this next interval? Goes from where to where? Yeah, 17/3 to infinity. What are the enclosures? Bracket, parentheses. Okay. Okay. Okay, you guys work on the next one, okay? Should have gotten somewhere to this. Again, you work them as two separate problems. Places people make mistakes. These are arithmetic mistakes, okay? That's the kind of mistakes people make. And then, like I said, the number line, I'm not wanting to grade the number line. I want your final answer in interval notation. The number line can be a nice intermediary visual. If you can get the number line, getting from here to interval notation is pretty short. Here's an interval, there's an interval. You just copy down the two numbers that you see, okay? 10 to infinity, -5, -infinity to 5. Get the enclosures right, and there's your final answer. Okay, let's look at the next one here. I want to break it into two separate problems, okay? So the first problem is what? Negative x plus 3 less than or equal to x plus 2. What's the second problem? X plus 2 less than negative x plus 8, okay? Now my goal is just to work on each problem individually, get an answer or two answers, and then pull those answers back together. Okay, what's the first step I want to do here? Add x to add what? Yeah, so if I add x to both sides, then I'm going to get what? 3 less than or equal to 2x plus 2. Now I do what? Subtract 2 from both sides. 1 less than or equal to 2x. Now I divide everything by what? 2. And I get 1/2 less than or equal to x. If I write that with the x first, that's going to be x greater than or equal to 1/2. Yes, question? Split the x plus 2 up. But no, you go from, you look at, you got two inequalities. So this whole thing is one inequality, and then this whole thing is the other, okay? So you copy from where you start to up to that second inequality, okay? So I've got x greater than or equal to 1/2, and then this one, what do you want to do first here? You can add x to both sides, and I get what? 2x plus 2 is less than 8. Subtract 2 from both sides. 2x is less than 6. Therefore, x is less than 3. Which of these numbers is smaller, 1/2 or 3? 1/2. So I write 1/2 right here. I write 3 over there. What does it mean to be greater than or equal to 1/2? What kind of number dot goes on 1/2? So closed circle, shade in which direction? To the right. What happens on 3? Open, shade to the left. How many intervals do you see drawn there? One interval. It's the interval from where to where? From 1/2 to 3. And what kind of enclosures? A bracket, parentheses. Okay? So this one, like I said, the key is break it down into two problems. This is the first problem right here, and this is the second problem right here, okay? Then you'll go off and work these two problems individually. You get two different answers. Merge those together on the same number line, and then read in interval notation what your final answer is, okay? What's the big thing that happens with the inequalities you got to be real careful of? When you multiply or divide what? By a negative number, what happens to your inequality? It switches, okay? So you have to be real careful with with that, with doing inequalities. Let me see if I can make one real quick that does that so we can do something. Let's just do an example of, let's say, negative x less than or equal to 4 less than this is going to give me, let's do this, see if this works, okay? Okay, so I break this into two problems, okay? First problem, negative x less than or equal to 4. What do I have to do on this one? Multiply or divide by -1, doesn't matter if it's which one. So the minute I multiply or divide by -1, this has to change, right? So this becomes x, what? Greater than or equal to -4. Okay? No. Either way, same thing. If you had negative x less than or equal to 4, if I divide by -1, I get the same thing. This has to change, so this is x greater than or equal to -4. Okay? And then over here, I've got 4 is less than 5x plus 6. So if I subtract 6 from both sides, -2 less than 5x, divide by 5. So -2/5 less than x, or x is greater than -2/5. So this one's a little bit complicated. X is greater than or equal to -4, and x is greater than -2/5. So on a number line, you've got -4, -2/5. So I've got this condition, and then greater than -2/5. I've got this condition. Okay. This one's, Well, what numbers are greater than this number and at the same time greater than this one? It's greater than this number and it's greater than this number. What numbers satisfy both conditions? Look at the drawing, okay? I need numbers that satisfy this part and this part at the same time. Pardon me? No? Okay. What numbers, are there any numbers that are on, do these two lines overlap at all? Yeah. Okay. That's where both conditions are met. Okay. So in this one, the solution is going to be from -2/5 to infinity. So this one's a little bit complicated, okay? The only way to meet both of these conditions is right here, from -2/5 to infinity. Okay? So what I wanted to illustrate was what happens with the negative sign. So I got a little bit more of a complicated problem that I wanted to get for your purposes. So where we are today, when you see a compound inequality, that means you see two or more, well, in your case, it's going to be two. You see two less thans, two greater than, or less than greater than. You see two of them. You break them into two inequalities, and then you just solve them as simple inequalities like we did in the last section. You draw the solution on a number line, and then you can look at that number line. You won't freak out if they're fractions, and then you pull this down into interval notation, which is just what we did, okay? So that should lead you to the end of this section, straight into homework, okay? So take a look at this. Guys, you should have plenty of time to work on the homework. Go ahead and work on that now. If you do have questions, let me know. But you've got a good deal of time right now in class to get through that. Okay?